Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in mathematics ranging from algebra through calculus and more advanced topics as well, please consider subscribing to our channel, checking out our playlists, watching our videos, liking, commenting, sharing. All of those things help us out and are greatly appreciated. Let's get into the current video. I want to take a look at the conjugate of a cube root. Now, you've probably seen, especially if you've taken, say, pre-calculus, certainly Calc 1, possibly some algebra courses, you've heard of the word conjugate, and more than likely you've heard of it in two instances. One, if you're dealing with complex numbers, which is related to what I'm going to be talking about, but I'm not going to mention anything about conjugates of complex numbers, but it is related to square roots. But more importantly, you probably heard it in the context of dealing with, say, square roots, where you have to rationalize a numerator or a denominator, and in particular if you're simplifying a square root, or the difference quotient of a square root. For example, if I look at the following, which is the difference quotient of the square root, the square root of x plus h minus the square root of x over h. This is a common expression in algebra, pre-calc, and calc courses that you might have to manipulate, and one thing that you might have to do with it is rationalize the numerator. In order to rationalize the numerator, what we do is we multiply by what's called the conjugate of the numerator. And the conjugate of the numerator is the exact same expression. However, I replace this sign with the opposite. If this is minus, this is plus. If this is plus, this is minus. And of course, I have to divide by the same thing. And we multiply the fractions together. Now, the idea is I'm only going to multiply the conjugate pair. And when I multiply the conjugate pair in this case, I'm going to get the square root of x plus h quantity squared plus the square root of x plus h times root x minus root x times the square root of x plus h minus the square root of x squared all over h times the conjugate. Okay. And then what happens when we simplify this? Notice that the square of the square root reduces to x plus h. The two middle terms are the same term but opposite signs, so those cancel. And then the last term here is the square of a square root, which gives me minus x. And then my denominator, which was h times the conjugate. In the numerator, notice that the x's cancel, leaving me with h over h times the conjugate. Of course, common factor of h cancels, and my final expression is the following. Okay. Now, we started with this expression up top here. This was the difference quotient of the square root function. Okay. And by manipulating it, notice I multiplied by an expression which is equal to 1, so I didn't change technically the values of the expression. I'm just manipulating it. I multiplied through by that, we simplified, and we come down to this expression on the bottom. Now this expression on the bottom that I ended with is equivalent to the expression on the top. And again, in your calc course, you're going to do something with this, especially if you are, the goal of here is to compute the derivative of the square root function. But the main idea is I had to rationalize the numerator, meaning I had to get the radical out of the numerator. Okay? And the way we do that is by multiplying by what's called the conjugate. Now, let me summarize this over here. And again, I just want to look at multiplying the conjugate pair. If I look at the expression we started with, which was the square root of x plus h minus root x, I multiplied by the square root of x plus h plus the square root of x. And what did we end up with? Well, notice that these two middle terms canceled, but what didn't cancel was the very first term and the very last term. And I want to write this the following way. This was the square root of x plus h squared minus the square root of x quantity squared. Yes, those reduce. Yes, they then combine to get just the h, but I want to look at this in a different way because this is going to motivate how we do the cube root or a conjugate of the cube root. If I look at this expression, well, this says, well, what if I have something like a minus b? Okay, so I've got the difference of two terms, and then I multiply by the sum of those two terms, and the result is I get the square of the first minus the square of the last. Okay, all I did is I replaced the square root of x plus h with a and the square root of x with b, and this right here in green here is equivalent to what I started this formula up top. Now this is a very famous and high, frequently used factorization formula, the difference of perfect squares. So this is the idea. If I have, at the very beginning, I've got a difference of two terms, and I want to somehow, and this has a square root, or one or both has a square root, if I want to eliminate the square root, I can't just take the square root of the whole expression. I have to, how can I get a square on the a term or a square on the b term? Because notice here, that's my end result. What I do is I multiply by what's called the conjugate. That is going to, this multiplying by the conjugate is how I put a square on the first term and a square on the last term. I may not need both. Here I did, but this is how I can put a square on this one and this one. I don't square the whole thing. I multiply by what's called the conjugate. Now, all that said, I want to take a look at how could I figure out a way to do the following. Suppose I have this. I've got the cube root of x. Let's do the cube root of x plus h minus the cube root of x all over h. Okay. For those that have taken Calc 1, you'll recognize that as the difference quotient of the cube root function, which is part of the process of finding the derivative of the cube root function using the definition of the derivative. So if you don't know what those terms mean, it's not a big deal. You don't need to know that for this. This will just be applicable for an algebra student or a pre-calc student where you want to find the difference quotient of a cube root. Okay, and I want to rationalize the numerator. Well, let's see. What I have is an expression on top, and I'd like to be able to multiply this by something so that way I can put a cube on this to get rid of that cube root and put a cube on this to get rid of this cube root. Now, I can't just cube the whole thing because cubes don't distribute through a difference. Okay, they'll distribute, an exponent will distribute through a product or a division, but it won't distribute through a difference. So therefore, what I have to do is I have to figure out a way that I could, like this conjugate idea, what could I multiply this whole expression by so that I can put a cube here and a cube here? Well, let's explore that over on this side of the board. Let me recap where we are. I have the following. And let's highlight just the numerator for a moment. I'm going to take the difference of the cube roots there. So I have this expression. I would like to multiply by something so that when I multiply that and I distribute all this through and I simplify all the terms, I'm able to take the first term and cube it to get rid of that cube root. And then I would like to be able to take the second term, which is again another cube root, and I would like to be able to cube that as well. And then of course then we can simplify that to just h, and then of course the h in the denominator, those kind of factors will cancel, and we'll see that story play out. My main thing is I want to be able to multiply this by something to eliminate those two cube roots. Okay. Well, this right here is the key. Notice if I had a square root, we used the difference of squares, factorization formula. Well, there is a very similar thing for cubes, right? The difference of perfect cubes. If you remember the difference of cubes, has the following factorization formula. A cubed minus b cubed it's the difference of the bases multiplied by a squared plus ab plus b squared. Okay. You don't have that memorized. It's useful to do so, although it doesn't come up as often as the difference of squares. This one, no matter what math class you're in, you should have that memorized. This one, once you're in, say, Calc 1 and there on out, you should have that memorized. So just write it down 20 times or something. Well, let's compare what I just came up with to what I have right directly above it. All right. Let's start over here. I've got the difference of cubes. Now ignore what's underneath. Ignore the cube root, square root, the cube root of x plus h. Ignore all that. Just, I've got the cube of something minus the cube of something. Well, over here, I've got the cube of something minus the cube of something. And then if I look at the other side of this, I've got, well, what I have in this first set of parentheses is the difference of two things. And notice those two things match what's under the cube here. So that would be my a minus b. Well, then that must mean that this expression right here is my conjugate. If I make the following identification, if I say a is the cube root of x plus h, and I say b is the cube root of x, then using this expression right here, a squared plus ab plus b squared, using these two a and b's, that will be my conjugate for this cube root expression. Okay? So the conjugate of the cube root of x plus h minus the cube root of x is the following. It's the cube root of x plus h squared plus the cube root of x plus h times the cube root of x plus the cube root of x squared. That looks complicated. It's really not that big of a deal. It's simply the a and the b that I identified here plugged into this expression that's labeled the conjugate. So a squared plus ab plus b squared. That's exactly what I have down here. Now, I'll show you the details, but if I take this expression right here that I have in the bottom, and I multiply the top and the bottom of this expression by that conjugate, I'll be able to rationalize the numerator. Okay, let's go ahead and let's check out those details. Start at the very beginning. This was the expression that I wanted to rationalize the numerator of. So what I'll do is I'll take this whole expression that I have in the bottom that I'm claiming as the conjugate, and I will multiply top and bottom by that. space down here, so I'm going to clean that up too. All right, now this turns into just a big multiplication problem. So let's go ahead and work out the details. If you want to pause the video and try to work that out and see what it simplifies down to in the end, and then press play and make sure your work matches mine, go ahead and do that. But I'm going to go ahead and I'm going to run through it. Now, rather than rewriting this whole expression at the bottom, because remember, I'm only multiplying the conjugate pair, I'm going to write the denominator. I'm going to write this whole expression down here. I'm just going to call it C for conjugate. And so therefore I get the following. I'll go ahead and multiply this out. I would have the cube root of x plus h times this one, which means that's that cubed, and then plus cube root x plus h squared, cube root of x, plus cube root x plus h times the cube root of x squared. So that's what I get when I take this first term here and distribute it through all three of those. Now let's distribute the negative cube root of x. That would give me negative cube root of x times the cube root x plus h squared minus cube root x plus h times the cube root of x squared minus the cube root of x cubed all over h c. So again, c just refers to this entire conjugate. Let's see what cancels. I know that I get the cube root of x plus h cubed, and then here I've got the cube root of x plus h squared, cube root of x. Let's see if there's a negative one of those right here. That says that this whole term here cancels with this one. And then I've got the cube root of x plus h, cube root of x squared. Same thing here, but this one's negative, so that cancels with that. And the only things that remain are the first term and the last term, which means this is minus the cube root of x cubed all over h times the conjugate. And of course, the cube of a cube root gives me x plus h. Cube root cube cancels, minus x all over h times the conjugate. And of course, the x's cancel, and then h's cancel. So my end result is the reciprocal of the conjugate. Now, we can do a very similar thing with a fourth root or a fifth root. We just need to use the factorization formula and then identify what a and b would be in those cases. Feel free to try some of those on your own, and maybe in a future video I will elaborate on how that actually works in practice. But thank you for watching, and please consider subscribing.